A titration is a volumetric analysis. This analysis depends on our ability to observe the progress of a reaction. To observe this, we need an indicator that typically allows us to determine at what point we have combined equivalent amounts of the two reactants. Read the theory section of the lab manual to better understand the following procedure. For the titration of calcium, we use areochrome black tea as our indicator. This indicator forms a red complex with calcium ions, but also with other ions such as magnesium and iron, and that is why we had to precipitate and to remove the iron prior to this titration. To determine the unknown calcium concentration in our scale sample, we add a reactant called EDTA. EDTA strongly complexes or bonds with the calcium ions, removing the calcium from the areochrome T indicator. And when EDTA has removed or ripped off all the calcium ions from the areochrome T, it changes its color and turns blue. Alright, let's go. We fill some EDTA into a beaker. We now condition a burette by flushing it with the EDTA solution. All that, like a whole burette full of EDTA, is discarded. And then we add some fresh EDTA into the burette, and it doesn't have to go up to the 0 mark. It just has to be at some level that we can record with good accuracy. For the titration, we now release the EDTA solution into our calcium solution, and we do that in 2 runs. The first one is relatively fast, and we just want to determine the approximate amount of EDTA solution we need. And in the second run, we repeat the whole process but become really slow with a really slow drop rate to determine the exact amount we need to react all the calcium with the EDTA that we add. With the first fast run, we determined the total volume of EDTA solution that was needed to complex the calcium in our sample. And in the second run, when we're just 1 milliliter away from that total volume, we slow down the release of the droplets until we're about 1 drop every 5 to 10 seconds. And then we will be able to determine the very last drop or even half a drop that is needed to change the color of our solution from almost blue to completely blue. And that, the closer we get to that point, the more accurate our result. Last step is to determine the volume of EDTA solution in the burette. We know the concentration of that solution, and we can now calculate, based on how much EDTA was consumed, how much calcium was in the flask containing 1 milliliter of scale solution with unknown calcium concentration. The titration is finished, and before we leave, we now pour all the liquids into a waste beaker. We rinse the burette with plenty of distilled water. All these rinses go into the waste beaker, and then everything gets poured down the sink with plenty of water. There's nothing toxic in our experiment, and we can then wipe down the burette with some disinfectant wipe and leave the lab, but of course not before washing our hands with plenty of soap.